Yes, all of you are welcome to the presentation on the chemistry, and that is especially the chemical bonding, which itself which correlates with the strength between the two atoms and formation of a new compound. Two atoms, when combined with each other to guess the different compounds. Examples are very good known: hydrogen and fluorine, both combined with each other and form the hydrofluoric acid or hydro. Similarly, hydrochloric acid, the hydrogen chloride, H and Cl. So, in between the hydrogen and chlorine, a chemical bond is formed. Similarly, in case of the table salt, which is sodium chloride, in case of the sodium chloride, sodium bond with chlorine. Sodium chloride itself is formed. Now, uh, the fundamentally atomic structures uh, in which the electrons are moving around the nucleus, and electrons role is very important in the chemical bonding. Electrons having the negative charge, and the magnitude is 1.6 into 10 raised to power minus 19 coulomb. So the electron role is very important in the formation of chemical bond. Even number of chemicals exist which are present on this planet. Even the extraterrestrial aspects, the importance of bonding is very, very well known. In the universe, different materials we get, and there is also the responsibility of the bonding between the two atoms. Even silicon oxide, that is the example of the silica. So this silica itself is very hard, whereas the hydrogen sulfide H2S, that is the gaseous condition. So physical state of that H2S is the gas, whereas the silicon oxide is the very solid. And similarly, in case of the carbon, that is one of the other things, and that is also in case of the carbon, various allotropes are present. So now the question is there how the bond forms, and what about the strength? So with the help of fundamental atomic structure, the subparticles present in atom, those are the electrons, negatively charged particles, and the weight is very, very little, whatever in range of the 10 raised to power minus 31 kg, and these electrons continuously moves around the nucleus. So nucleus, and then continuously electrons are surrounded. Now, one atom, another atom. So in one atom and another atom, there will coordination between the two atoms with the help of the electrons. So electrons were the moving continuously. So how one electron of one atom and this combined with another atom. This is the bonding. Whatever if suppose we have the sorry, family members having the bonding, the so two peoples having the bonding. So that relationship and continuously helps their the strength. So similarly here, if suppose we have the sodium atom and chlorine atom, both combined with each other, formation of the solid state sodium chloride, that is the ionic compound. So that is the electrolyte, and that is soluble in the water. One thing. Similarly, in case of the CH4 methane, the condition is the gaseous condition. Physical state of methane is gas. So how this bonding occurs between the carbon, hydrogen in methane, and in salt, sodium chloride in between the sodium and chlorine. So that's because of the magic of the electron. So existence of electrons in an atom, and there is the excellency in participation of the bonding. So chemical bondings are of various types, and it gives the strength of the atom, and that gives finally answer the compounds. So compounds will be the. So here different roles of compounds are there in different technologies in even in our life. So now chemical bonding are the bonding between the two or more atoms, relatively more strength in the different atoms. So chemical bonds are generally of three types: the ionic bond, covalent bond, and coordinate bond. However, there may be also there. So today we discuss about the covalent bonds. First of all, we have to go towards the covalent bond. Whatever there may be, the electron configuration of element is responsible for any of the chemical bonding. So, electronic configuration of element is very highly responsible for the bonding, and their the strength, even they are the physical state, they're the functional values of different compounds. So, when we have the periodic table, the alkali metals, alkaline earth metal. In group 1, alkali metals, whatever the hydrogen, this is the case. Then we have the lithium, sodium. Alkaline earth metal start from the beryllium and magnesium, then the calcium. So here the question is there. These are the s block elements also, because electron is in s subcell or atomic orbital, and that is of outer shell. So outer shell electrons are also the valence electron. So the question here, the electronic configuration of different elements gives and defines the bonding between the two elements. Here, sodium bonded with the chlorine. Here we can see the sodium having the electron 11 electron, and the configuration is like that: 1s2 2s2 and 2p6 and 3s1. So in 3s, one electron is present. In case of the chlorine, the 17 electrons are there, and they are respective in configuration, where 1s2 2s2 2p6 10 electrons, then 3s2 and 3p5. So here 7 electrons are there. So now the question is there, how they form the bond. Here, whatever there are the atomic properties of elements are there, and in which different electron atomic properties have the role, whatever the ionization potential, and then electron activity, electron affinity, whatever the size also. So here the configuration is most important in formation of the bond. So here we have already discussed the ionic bond in between the sodium and chlorine. Sodium chloride is formed. So sodium first of all become the sodium cation, this one, because of the electropositive elements sodium. So sodium cation, and how this can be easily formed because of the electropositive element. In case of the chlorine, that can take one electron, and that is the chloride. So chloride ion is formed here, sodium ion. So therefore, the ionic compound is there. But now we have to come towards the carbon compounds. In case of the carbon compound, hydrocarbons. What are the hydrocarbons? The carbon and hydrogen compounds. So the chemical bond in between the carbon and hydrogen. So here, if we have the electronic configuration of carbon, 1s2, 2s2, 2p2. 6 electrons are there in carbon, where the outermost electron in carbon are the 4. So 4 electrons are there, and so therefore here also we can say that that is also the valence electrons, and carbon can combine with 4 single bonds. So therefore the carbon and 4 hydrogen becomes the methane. So methane having the 4 carbon hydrogen bond. Here the bond is of covalent type. So in case of the covalent bonding, electrons are shared from one atom to another atom and form electron pair. So this one is because of their chemical bonding. Here the concern the carbon and hydrogen. So hydrocarbon itself, the well-known example is the methane. So one carbon combined with 4 hydrogen atom, and that is the covalent bond. So here we can say on this planet, various compounds are in the stable form. Whatever, if suppose we are concerned about the space research, in which the Mercury, whatever the research on the moon, so which are collectively responsible by the chemical bonding between two elements. So here we have to back that ionic compound and covalent compounds and coordination compounds. What are the responsibility uh, of electrons? So electrons are responsible for all types of bonding. So in case of the covalent bond, electrons from two or more atoms the share of their respective electron, and electron pair is formed. So in case of the electron pair formation, uh, one electron from one atom and one electron from other atom, so therefore one electron pair will be there. If suppose two electron pair are there, so therefore in that particular case, two electron pairs, and where two electron from each of the atom, and we get the double bond. Similarly, here we also get the triple bond. Triple bond, that is because of the 3 electron pairs are there, and in which each atom provide the 3 electrons. This one is also well known in organic compound. The main, the simple example of triple bond is carbon, triple bond carbon. So here CH triple bond CS, that is acetylene. So acetylene having the triple bond. So here the 3 electron from 3 carbon and 3 electron from the another carbon. Formation of carbon triple bond carbon. Ethylene, the double bond is formed. So these are the examples of the respective bonding. Single bond, double bond, and triple bond. So multiple bonds are there. Even the carbon triple bond nitrogen may be existed, and that is the cyanides. So here we have the different classes in the periodic table, and which are responsible for whether the ionic compound or covalent compound or the coordination compound, which will be formed, which type of bonding, which type of compound, and whether we can say the form compound is very strong. Silicon oxide. So the silicon oxide very hard, that is of the sand. Carbon dioxide, that is the gaseous. Oxygen O2, oxygen, oxygen, double bonding. So, which type of, even in case of the water, the life of a human being, two hydrogen and one oxygen. How they form? So this is because of the bonding and chemical bonding. Ammonia itself, NH3. So that is the gaseous in the condition. So let's we have continue for that, and so periodic table is one of the responsible. And before going to periodic table, we have the here is the filled electron shell. This is the most important aspects. Here we can say the filled electron shells and which are very stable. We have already discussed in the periodic table, and that is the inert gases. So inert gases, and so they have the fulfilled all those electron shells are filled with 8 electrons. So in case of the inert gases, or helium, neon, argon, and respectively. To fill electron shell, which are very stable, and that's why uh, helium, neon, and argon are very stable, and even those are inert in condition, so not reactive. So whereas in case of the sodium, the alkali metals react fastly. In environment, it is impossible to get sodium metal, because when if a sodium metal is there in the environment, immediately this will react with the moisture or whatever the other materials, other gases, and so this is because of the whatever the one electron outside outer electron. So that is given up easily. That is electropositive in case of the sodium, and then formation of inert gas cause. So this one is most important concern, that here that for the stability, any of the atom, the part of the element want to combine with other immediately, and this depends on how many electrons are present in the outer shell. If one electron is present in outer shell, then easily this can be given. If 7 electrons are there in outer shell, then it will take one electron. So electropositive, electronegative elements, that is the description. Holy periodic table is there and describe the positive and the negative. So here we have to continue. That is the structure where the outer shell electrons are the uh, 8 electrons. So 8 inside, so 2 plus 8, even this one is the inert gas, and 18 electrons are there. So filled electron shell are very stable. So this is one of the fundamentally electrons, and this is responsible to gives us whether the compound is solid, whether the compound is liquid or in the gaseous form, and how much this is stable. That only depends on the over the electron affair. Electron may be paired, electron may be transferred, electron pair may be transferred. So dative donor, that is we have already discussed in case of the covalent bond. So deficiency, electron deficiency or electron richness, both are important concern. So this is the last one, and so here for stability, want the octet, the outer shell or electrons. Here, suppose we have the chlorine 17, chlorine want to take one electron and get the 18 electron, and here the Cl minus having this configuration. So 2, 8 plus 8, Cl minus, that is the chloride. So that is the stable. So why bonding needs? So bonding needs because of the electronic configuration. How many electrons are there? That is the thing. So let's have to continue this one. Now let's see this bonding between the different elements. How we can get the different compounds, and that is because of the even fluorine F2, the chlorine Cl2, two chlorine atom, and the electron pair is formed by two electrons, and each electron out of the paired electron, one electron came from the each of the chlorine atom. So here we can say the hydrogen, then the nitrogen, here the oxygen, the chlorine, bromine, and iodine. So these molecules form whatever the we have only have hydrogen atom. So hydrogen atom there, hydrogen get the inert gas configuration. So this one hydrogen combined with the another and form. So in that particular case, H2, one electron pair is formed, and that electron pair is the bonding. So here are different compounds where we get the halogens, and in case of the halogens, the fluorine, chlorine, bromine, iodine. Different sizes are there of those atoms, and here the bonding is there. So this is one of the how bonding between different elements, and that depends on their respective elements. And so here we can say summarize the bonding and structure. So here the type of bonding in a substance affects the properties of that substance. Can you imagine the gaps in the table? Whatever ionic compound, giant ionic lattice structure. Whatever sodium chloride, millions of metals and non-metal ions participate and form a specific structure. Whatever the design of that particular compound. So sodium chloride, the design of the different metal means the sodium and Cl chlorine, and they are rest. They have a defined structure. So the solid state, whatever I already discussed, that is this one ionic compound, sodium chloride. Then covalent compounds, we have the various examples, the simple molecular. In case of another, that is the giant covalent or lattice. In that particular case, covalent compounds. So CH4, methane, acetic acid, CH3, COH. Here, whatever there are also, along with carbon, other inorganic compounds, metals are also, and they form the giant covalent lattice. So that become the solid. For so many of the examples, the solid example having the covalent compounds, whereas in case of the simple molecule, and those are liquid or solid, various examples of carbon. So formation of those particular, whatever the here we can say the number of compounds. Here also the metallic lattice, which is also responsible that. So responsibility of electron is mercury and liquid, solid itself, and that is the metal. So millions of metal ions are present in the sample of the mercury liquid. The position of the mercury is the liquid. So except that the giant metallic lattices are formed because of the solid. So ionic, covalent, and metallic. These are also the type. So we can say different compounds are formed, and there is the responsibility. Now, the next slide we have to see, and this one is what we can see, and chemical bond. Hydrogen. Back to the electronic configuration where hydrogen itself having the one electron and carbon the six electrons. So carbon six electron in outermost four electrons are there. So carbon we have already discussed carbon 6, 1s2, 2s2, 2p2. This is the electronic. Hydrogen 1s1. So how the different covalent compounds are formed. In case of the water, oxygen. Atomic number of oxygen is 1s2, the electronic configuration. So here 8 electrons are there. Out of 8 electrons in oxygen, 2 electrons are in first shell and 6 electrons in the after shell. So 1s2, 2s2, 2p4. So total 8 electrons are there. So out of these 8 electrons, there the 2 electrons are less to get the octet condition. In outermost 8 electrons filled. So later we have to see the various examples and carbon, hydrogen and oxygen. The simple organic compounds are hydrocarbons. So we can see the most important relevant of the carbon. Carbon having the most one, we have to see carbon is the tetravalent and responsible for many things, the carbon. Then we have the water. In case of the water, H2O. So two hydrogen and one oxygen combined. Formation of the very great, excellent, life supporting material, water. H2O. So H2O, the covalent bond sharing of electron. So 6 electron from the oxygen. Out of 6 electron, 2 electrons share with the two uh, respective electrons of two hydrogen atom. So H2O is formed. In another case, we can see the ethyl acetyl. So what happened? We have discussed the water H2O, hydrogen, oxygen, single bond, covalent bond. So two covalent bonds are there in case of the CH H2. So two covalent bonds, one hydrogen with the oxygen. So here the formation of the H2. Two covalent bond because of the sharing of electrons. So two oxygen hydrogen bonds are formed in case of the water. Now we have to come back to the earlier discussion of the double bonds. So double bond, triple bond, those are the multiple bonds. So double bond, triple bond, we have how they can describe in covalent bonds. So covalent bonding, the double bond, whatever the definition, and that clearly indicates that two electron pairs are there. Out of two electron pair from one atom, so one here two electron from one carbon and two electron from the another carbon, and formation of two electron pair and double bond is in between carbon, double bond, carbon, ethylene, ethylene, ethane, iopcine, CH2, double bond, CH2. So that is the ethylene. So here double bond itself in great opportunity for the different compounds. So different organic compounds or number millions of organic compounds are present, and that is because of the multiple bonding nature of the carbon. Here in the triple bond, that is of the carbon triple bond. So let's we have to continue. Hydrogen, carbon, then water, the electronic structure. We get oxygen surrounded by the six electron pairs. So in case of now the acetylene where the triple bond is formed. So three electron from each carbon atom, and those gives the carbon triple bond carbon. Now here one of the very dimensional aspect of the chemical bonding in covalent compounds. So here even in covalent compounds are also similar to the ionic compound in their dimensional aspect and structural aspect as well as the bonding. So structural and dimension that supports the productive compounds. So those are the functional compounds are formed, and even number of technologies which the dimension of molecule of the bonding is very highly responsible to get the structural aspect of bonding. So here this one is the now covalent bond. How this can be formed. This is the example of the chlorine. Cl2, two different chlorine atom. Two chlorine. You can see the electronic configuration of chlorine. How many electrons are there? What is the atomic number of chlorine? The 70. Then the electronic configuration as clearly indicates in the above slide. So covalent bond this consists of shared pair of electron. Electron pair is responsible. So one of the chlorine and here electronic configuration of chlorine. So where how many electrons are there in outer shell in case of the chlorine atom? You can see the electronic configuration. 1s2, 2s2, 2p, 1s2, 2p2, 1s2, 2s2, so 2p6. So total 10 electron, and then the next is the 3s2 and 3p5. So one electron is essential, whatever I have earlier discussed, and in case of this, so here their stability is only because of uh, the outer shell 6 electrons. So that sorry 8 electrons. So that one is the stable. Here you can get the chlorine gas Cl2, and that is the one chlorine atom and another chlorine atom and formation of the covalent bond. So covalent bond consists of the shared pair of electron, and the right of both chlorine atom is also there. So on the shared electron pair. So only outer shell of electrons are involved in bonding, so that inner shell do not always have to be included in this diagram. Here, two common ways to represent a covalent bond are this one is the whatever we have already discussed, very simple communication, and that is the covalent bond is formed. So chlorine. So here we get the Cl plus Cl compound. Here we can say the bonding in the methane. That is also the covalent compound CH4. Carbon, the tetravalent. Okay, outermost four electrons. Hydrogen, monovalent. Monovalent hydrogen. Carbon, tetravalent. Covalent bonds are formed in between the four carbon hydrogen bond. So we can say the covalent bonding. Covalent bonding, the sharing of electrons. The methane, CH4, 4 of hydrogen, and 1 is the carbon. So carbon electronic configuration and hydrogen electronic, and then stability. That is the octet followed by the octet group. So here, in case of the CH4, I can also, yes. So here the 2 4 carbon hydrogen, one electron needed to get the inert gas configuration or more stability, that is 4 from the carbon, and ratio of atoms, this will be 4 in hydrogen and 1 in the carbon. So electron needed, 4 electrons are needed uh, for carbon, and 1 electron needed for the hydrogen to get the inert gas. So this one is the fundamentally known and the basic of the methane. CH4, methane, and the electronic configuration, carbon, 4 of hydrogen bonding, and what we have, we get the methane. So here methane having the carbon, one carbon, 4 electrons, and 4 electrons from the 4 of hydrogen atom, and formation of 4 electron pair, or we can say 4 covalent bonds are formed. So 4 covalent bond is carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon. And finally we get the chemical bonding also. So here the pick is itself is given, and that is very sufficient. So what we have, CH4 itself will be carbon, hydrogen, and this one. So let's continue for that, and we have to come towards the most. That's there are certain examples, certain uh, problems which we can solve. This is the covalent bond, which is not an exception to the octet. Here, four compounds are there. Discuss one by one: boron, chlorine, boron trifluoride, the tin, tetrachloride, beryllium. So here, beryllium iodine, chlorine, oxide. So out of the answer itself is the B. Why this B? Because all follows the octet. So that's tin, not an exception to the octet. So here the tin itself, whereas the others are the deficient. BF3 already this is well-known compound. So here not follow the octet rule. Whereas this tin exhibits the opposite. The self-linking ability of carbon, this is one of the great property by which the various covalent compounds are formed. So the self-linking ability. What about the linking? This is the bonding. So why? In case of the carbon, a great bonding is there. Even the multiple bonding is there. Carbon single bond, carbon, carbon double bond, carbon, carbon triple bond, carbon. Various examples. And that carbon combined with the uh, whatever then set, satisfied with the saturation for that purpose. So why this carbon having the continuously linked component, so many, a great number, if a 10 carbon atom combined with each other and formation of the long chain, the branch chain, so that is the process, and it is the isomerization. But what is the word for the self-linking ability of carbon? So first one is the catenation. So what about this? The catenation, sublimation. What about the iodine? or camphor, naphthalene. So this supply that directly from the solid to gaseous condition, sublimation. Hydrogenation, addition of hydrogen, then the carbonation, so whatever. So here the answer itself is the catenation. So in case of the catenation, continuously they form the link with another carbon. Formation of long chain hydrocarbon, long chain carbon compound, and that is in case of the various number of organic compounds. So answer is the catenation. Self-linking. If one carbon is present, another carbon is present, so there will be formation of the link, and this one is the catenation property. Because of the catenation property, at the present context, number of organic compounds as compared with the inorganic compounds. So the catenation itself is the right answer. Here sublimation. Now CCl4, this one is insoluble in water. Why this? Insoluble. Answer non-polar and water is polar. So polarity appears. How this polarity appears? So how non-polar is there? Water is non-polar and CCl4 is polar. The B answer. The C option. Water and CCl4, carbon tetrachloride, both are polar. Or from the none of above. Carbon tetrachloride, CCl4. Why? The carbon combined with the chlorine atom. How many chlorine atoms are needed? Four of the chlorine. This one non-polar and water itself is the polar. So why? Both are the covalent bond. So this is because of the another specified properties of atom, and that one is the electronegativity. So electronegativity itself clearly indicates that how electron pair can be forced towards that respective elements. So that is the electronegativity for the attack. How to get uh, the their electron pair, and that is present in the bonding. That one is also concerned. So here the right answer is the CCl4, which is insoluble. Even such uh, big properties appears. The solubility, solvents, the solute. So here, because of the bonding, what we have polarity in the solvent, non-polar solvents. So why? This one is because of the bonding, and that is most responsible. Even the polarity or non-polar solvents. So polar solvents are easily same to same. Polar solvent mixing, non-polar solvent the mixing. So that is the question of their the solubility. So now we can continue, and the answer the A part. Almost 95% of compounds are carbon. This one is also because of the multiple bonds. Carbon triple bond nitrogen, carbon double bond oxygen, carbon single bond carbon. So single bond, double bond, and triple. This is not the answer. Multiple bond. Why? Multiple. Catenation of carbon atom. Covalent compound. Sharing of electron. So here the answer itself is the. Now we can say various examples. Which one is the covalent compound? The first one, ethane C2H6. So two carbon atom and the six hydrogen atom. In case of the aluminium chloride, electron deficient because aluminium having the three electrons in outer shell, and then this combined with the three of the chlorine, so electron. Similarly, here are also the various examples: calcium chloride, mercury chloride. So overall, we can say the covalent bonds are very responsible and the great value additions are there in the forming compounds. As we have discussed, the CH4, silicon oxide, the water, H2O, then HF, hydrofluoric acid, HCl. So, number of the covalent compounds are discussed. So, that is most important concern in our life also, because the protein, carbohydrate, fats, those are also responsible, and those are because of the covalent bonds. So this is all about. Anyone have the question, queries, then he or she can ask me on my mobile number, or can share the whatever that things. So this is all about covalent compounds are most important concern, and mostly important life also. So just those are the proteins,